Namaskar, I am Biju Dharmapalan and you are watching Science Time, a show that brings you the latest developments from the world of science and technology. Let's first look at some of the exciting stories. Plant toxin hailed as a new weapon in the war against bacteria. Study shows Earth's inner core may be reversing its rotation. AI has designed bacteria-killing proteins from scratch. Now let us see the news in detail. Scientists have discovered a plant toxin whose unique method of dispatching bacteria could be used to create a powerful new range of antibiotics. The prospect of developing new antibacterial drugs this way has been hailed by doctors who have been warning for many years that the steady rise of multi-drug resistant pathogens such as E. coli now presents a dangerous threat to healthcare across the planet. According to a research carried out by a group of British, German and Polish scientists, the new antibiotic albicidin attacks bacteria in a completely different way to existing drugs. The results of the study is published in the journal Nature Catalysis. The study suggests a new route that could be exploited to tackle the bacterial diseases in humans. Albicidin is produced by a bacterial plant pathogen called Xanthomonas albiniens that triggers a devastating disease known as leaf scald in sugarcane. The pathogen uses albicidin to attack the plant, but it was also found several decades ago that it was highly effective at killing bacteria. Now let's move to the next story. It seems our planet may have had a recent change of heart. Planet Earth's inner core may have stopped turning and could go into reverse, according to a study published this week. Earth is formed of three layers: the crust, the mantle and the core. Made almost entirely of metal, specifically iron and nickel, Earth's inner core rests 3,200 miles below the crust, separated from the mantle by the liquid outer core, which allows the inner core to rotate at a different speed from the planet's rotation. Earth's inner core may have temporarily stopped rotating relative to the mantle and the surface, researchers report in the recent issue of the journal Nature Geoscience. Now the direction of the inner core's rotation may be reversing, part of what could be a roughly 70-year-long cycle that may influence the length of Earth's days and its magnetic field. Though some researchers are skeptical about this. Buried about 3,200 miles below the planet's surface, the inner core reaches an estimated 9,000 to 13,000 degrees Fahrenheit. It can't be accessed for samples or direct measurements of its spin. Instead, researchers studied seismic waves from repeating earthquakes that have passed through the Earth's inner core over the last 6 decades to infer how fast the inner core is spinning. According to the researchers, the inner core's rotation came to a near halt around 2009 and then turned in an opposite direction. There is little to indicate the inner core's rotation has any effects on humans. The scientists study the inner core because its properties may affect how fast the Earth spins and thus how long a day is, as well as the planet's magnetic field. Now let's move to the next story. An artificial intelligence or AI has designed antimicrobial proteins that were then tested in real life and shown to work. The same approach could eventually be used to make new medicines. Proteins are chains of amino acids. The sequence of those amino acids determines the protein's shape and function. Ali Madani at Profluent, a biotechnology startup based in California, and his colleagues used an AI to design millions of new proteins, then created a small sample of those to test whether they worked. The AI, called Progen, works in a similar way to AIs that can generate text. Progen learned how to generate new proteins by learning the grammar of how amino acids combine to form 280 million existing proteins. Instead of the researchers choosing a topic for the AI to write about, they could specify a group of similar proteins for it to focus on. In this case, they chose a group of proteins with antimicrobial activity. The researchers programmed checks into the AI's process so it wouldn't produce amino acid gibberish, but they also tested a sample of the AI proposed molecules in real cells. Out of the 100 molecules they physically created, 66 participated in chemical reactions similar to those of natural proteins that destroy bacteria in egg whites and saliva. This suggested that these new proteins could also kill bacteria. The researchers selected the 5 proteins with the most intense reactions and added them to a sample of Escherichia coli bacteria. 2 of the proteins destroyed the bacteria. The researchers then imaged them with X-rays. Even though their amino acid sequences were up to 30% different from any existing proteins, their shapes are almost matched naturally occurring proteins. The work is published in the journal Nature Biotechnology. Now let's move to Science Quest segment. The question for this week's Science Quest is, can saliva change the flavor of food? Scientists have long understood some of saliva's functions. It protects the teeth, makes speech easier, and establishes a welcoming environment for foods to enter the mouth. But researchers are now finding that saliva is also a mediator and a translator, influencing how food moves through the mouth and how it sparks our senses. Emerging evidence suggests that interactions between saliva and food may even help to shape which foods we like to eat. The saliva is neither very salty nor very acidic. Its water and salivary proteins lubricate each mouthful of food, and its enzymes such as amylase and lipase kickstart the process of digestion. This wetting also dissolves the chemical components of taste or tastings into saliva so they can travel to and interact with taste buds. Through saliva, we detect chemical information of food, the flavor, the taste. Saliva can also affect aromas, which are responsible for the vast majority of our perception of flavor that arise from food in the mouth. As we chew, some flavor molecules in the food dissolve in the saliva, but those that don't can waft up into the nasal cavity to be sensed by the multiple receptors there. As a result, people with different salivary flow rates or different saliva composition, especially of proteins called mucins, may have very different flavor experiences from the same food or beverage. Saliva also plays a major role in our perception of texture. It also helps us to perceive the difference between high-fat and low-fat foods. Even if 2 yogurts looks the same and pour the same, a low-fat version feels drier in the mouth. Through saliva, we detect chemical information of the food, the flavor, and the taste. Fully understanding these interactions between saliva, food, and the mouth, and how the information transfers to the brain could lead to the design of healthier foods. With this, we come to the end of this edition of Science Time. Keep sending your feedback and suggestions through email. Our email ID is indiascience@vigyanprasad.gov.in. We will be back with more exciting stories from the world of science next week. Stay tuned to India Science.